Hello everyone and welcome to a new video. In this video we are going to solve exercises that related to chapter 2, Introduction to Motion. A golfer puts on the 18th green at a distance of 5 meters from the hole. The ball rolls straight in the positive direction but overshots the hole by 1.2 meters. The golfer then puts back to the hole and sinks the putt for par. Part A, what is the distance traveled by the ball? Recall that the distance traveled by the ball or by an object is the total length of travel. Knowing that the ball travels 5 meters, then 1 meter, and go back to the hole with 1.2 meter also. So we need to add all the length together in order to find the total distance or the distance. So simply part A, we apply this addition. The first length is 5 plus 1.2, and we have also a distance, a length of 1.2 in the opposite direction. Add them together, we will get that the distance is equal to 7.4 meter. Why it's meter in meter? Since we add all the length in meters, so we should have the final answer also in meter. Part B, what is the displacement of the ball? Recall that the displacement is the net change in the position, and we can apply this formula in order to find the displacement. Delta x is equal to x final minus x initial, taking in consideration only the final position and the initial position. The initial position, suppose it starts from the origin, so the initial position is 0. The final position is the position of the hole, so x final is equal to 5 meter. Substitute this in our formula, we will get that the displacement should be 5 meter. Remember that the distance should be always positive, and displacement, it may be positive, negative, or even 0. Okay, question number 8. A billiard ball travels 22 centimeters in the positive direction, hits the cushion and rebounds in the negative direction, and finally comes to rest 7.5 centimeters behind the original position. So the ball starts its motion from this position, goes until it reaches the cushion, rebounds, and keeps move until it reaches the final position, which is 7.5. Let's suppose that the starting point is the origin, so x is equal 0 here. At this point we have x is equal 22, and we have here x final, this is x initial, and x final here, the final position is equal, since we are on the left hand side of the origin, this is the origin, so x final is minus 7.5. Okay, part A, what is the distance covered by the ball? Recall that the distance is the total length of travel. So we need to add all the length here. We have 22 in the positive direction. After rebound we have another 22, then we need to add the 7.5 centimeter. So 22 plus 22 plus 7.5. Plug this in the calculator, we will get that the final answer is equal to 51.5 centimeter. Okay, part B, what is the displacement of the ball? The displacement is the net distance traveled by the the object, we can apply this formula in order to find the displacement x final minus x initial, take in consideration only the final position and the initial position of the object. According to our graph, the initial position and the final position are shown here. So the final position minus, it's minus since we choose this point as the origin, and since the ball is on the left hand side of this origin, so we should have a negative position in this case. So we need to write minus 7.5 minus the initial position at the starting point, which is 0. So we will get the answer minus 7.5. Recall that displacement, it may be positive, negative, or 0, but the distance is always positive quantity. Okay. A train on straight track goes in the positive direction for 5.9 kilometer. Let's choose the starting point x initial at the origin, and then the train should cover a distance at this position which is equal 5.9 kilometer. Then the train backs up for 3.8 kilometer, then goes to this point. The distance here between this position and this position is 3.8. So let's define or determine the position of this point with respect to our x-axis. We can easily find this position by subtract 5.9 minus 3.8. Plug this in the calculator. We will get that the distance is 2.1 kilometer, or the position is, so this is the final position, which is equal 2.1 kilometer. Part A. Is the distance covered by the train is greater than, less than, or equal to its displacement? Explain. Okay, the portion of the journey that is in the negative direction will decrease the magnitude of the displacement, but increase the distance traveled. Therefore, the distance covered by the train is greater than, so it's greater than. Is greater than the displacement. Part B. What is the distance covered by the train? Recall that distance is the total length of traveling. So distance is equal, we have here 5.9 kilometer. We need to add it to 3.8 kilometer. Plug this in the calculator, we will get the answer, and the answer is 9.7 kilometer. Okay, part C. What is the train's displacement? We know that the displacement is the net change of distance. So delta x is equal x final minus x initial. We can simply apply this formula. Take in consideration only the final position and the initial position. The final position in this situation is 2.1. The initial position is 0. So the displacement 2.1 kilometer. So this is the displacement. Thank you for watching. See you in the next video soon.